Hello, I wanted to give you this example. We're still on polynomial functions. And here's what a polynomial function looks like on a graph. This is a polynomial of higher degree, which means it's degree 3 or higher than degree 3, I mean like degree 4 or 5. And in your book you have some exercises to do which gives you a drawing of the function like this one, similar to this one, and it tells you that that the function is a degree 5 function. So that means that this function has an x term with an exponent of 5. That's what degree 5 is. And it also tells you that the leading coefficient is 1. So I don't know what this function is. I can see the drawing, but I don't know what the function is. But I do know by the information they've given me, I do know that I'm going to use pink. I do know that my function starts off with a term like this one because it tells me it's a degree 5 and it tells me that the leading coefficient is 1. And they want me to use the factor theorem to find the polynomial. They want me to find the whole polynomial. Okay, and it gives you a hint. What are the zeros of f of x? Okay, and what does the factor theorem tell you about that? So, first of all, what are the zeros of f of x? On my previous video on the factor theorem, in the beginning of the video, I explained to you using a quadratic function about what the zeros are, what the factors are, etc. Okay, I'm going to go over that a little bit again, not a lot. And hopefully you'll be able to figure out along with me how to find the rest of the expression, right? Because this is longer. When we discussed the quadratic function on the previous video, I don't remember what the function was. Let's see, it's x squared plus x squared plus x minus 6, okay? And we went ahead and we factored this. We found x plus 3, x minus 2. And to find the zeros, or the x-intercepts, which is the same thing as finding zeros, we would use the zero product property rule, which tells me that if something times something is equal to 0, then one of these has to be 0. And I state that. And since I don't know which of the two is 0, I state that both are equal to 0, and I solve. And these numbers that I just found are the x-intercepts. That means if I were to draw a graph here, I would have at -3, I would have a point here, and at 2, I would have another point, okay? This is what we discussed in the previous video. But what's important is we went from having the function to finding the intercepts. Now I'm giving you this graph. I don't know the function, but I do see where the intercepts are. So do you think we can write up a function knowing the intercepts? Yes, we can. What we need to do is write these as factors of the function. Okay? Because I know that these factors are all x-intercepts. So let's look at the x-intercepts. This x-intercept here, this is 1, 2, 3. This is -3. This x-intercept is -2. The next x-intercept happens at 0. The next one happens at 1. And this one happens at 2. So for this x-intercept, if this x-intercept is -3, like we had here, x-intercept of -3, that came from a factor that read x plus 3, right? So if I have a -3 here as an x-intercept, I know that I have a factor that will say x plus 3. If I have an x-intercept of -2, then I have a factor that will say x plus 2, so that when I solve for x, I'll get -2. If I have a factor of 0, that means that if I have an intercept at 0, that means that I'll have a factor of x. Or you can say x plus 0, right? Or x minus 0. It's the same thing. When you solve for x, you'll get x. X equal to 0. If I have an x-intercept at 1, then my factor for that must look like x minus 1, so that when I solve for x here, I will get x equal to 1, which is the intercept. So I'm working backwards. And for this intercept, x at 2, then this factor must be x minus 2. So notice that basically what we've done, if it's a negative, I use plus. If the intercepts are positive, I use minus. And if it's at 0, I use x. So I have found 1, 2, 3, 4, 5 terms, 5 factors of this polynomial. So I can say that f of x for this graph is equal to x plus 3 times x plus 2 times x minus 1 times x minus 2 times x. So we've worked backwards. We went from the graph to finding the factors. If we were working the other way, we would have these factors. I would have to solve each of these for x, and I would have these intercepts. If I equal x plus 3 to 0, I would get x is -3, and I would plot my x-intercept at x equal -3, okay? But in this case, they give us the graph, they give us the intercepts. I have to figure out what the factors are, and there they are. How do I find the end factor? Well, you have to multiply all of this out. So let's start multiplying these two first. And I get x squared plus 5x plus 6. And now I multiply this times x minus 1 times x minus 2 times x. Let's do these two now. And I get x cubed Give me a moment here, because I've already done all this. I don't want to go through it again. Here it is. I get x cubed plus 4x squared. At home, you can do these step by step. But since I've already written it out, it's not going to fit if I do the whole thing step by step, okay? So I get that times, I still have to multiply by x minus 2 and by x. So now I multiply this whole thing by x minus 2, and you get x to the 4th power plus 2x cubed minus 7x squared minus 8x plus 12. And now I do my last multiplication, which is multiplying this whole thing by x. And that is going to equal x to the 5th power plus 2x to the 4th power minus 7x to the 3rd power minus 8x squared plus 12x. And there is your polynomial that they wanted you to find. Notice it is a fifth degree polynomial and the leading coefficient is in fact 1. So we've worked backwards. We found our polynomial, and that's how you do these sorts of problems. Careful here with the intercepts. If you have an intercept of -3, this does not mean that my factor is x minus 3. That is wrong. The factor is x plus 3. Okay, be careful with these. I hope this helps you with your 2 homework problems. You have 2 graphs to find the polynomials for. Okay, have a great weekend, and I'll see you.